curtain.
I was there like in the 3rd grade.
Might have been right between those two. Yeah, I mean, maybe I'm mistaken about my timeline, but I think it's been since then. Like a couple years ago, a student of mine went to go look at Paris because she wanted to enroll in a college and do an exchange program. She picked the college because of the exchange program. And when she went to go look at Paris for the exchange program, it's in Paris, right? When she went to go look at it, they had like a metal scaffold, and it was draped with this curtain that was like a painting of the art itself, but you couldn't actually see it because workers were inside. And maybe in that renovation they made that. Or maybe it was always there, I don't know, but something about the acids eating it up, that's what caused it. Maybe, because I'm sure there wasn't a restaurant on top when it was first built, so somehow that's on. Alright, anyway. Big problem for masonry, sky rises, marble, paint. Paint falls apart in acid. Number 4. Wait, was that number 4? Yeah, it might be, dog. Number 5. Let me see this. Starting over. Soil, pH, and microbes.
Yeah.
Aquatic organisms, breathing and breeding. Dissolving chemical elements which freeze up heavy metals, that's very dangerous. Dissolving building materials, which is just a hassle for civilization. And number 5, the big risk to you is if they are delivered to the inside of your lung by particulates. Like I mentioned before, the reason we worry about particulates is not because ash and dust are on their own that bad, although there was a story on NPR this morning about how they actually are also bad. But the bigger problem is they're like a boat that delivers other types of pollution to your bloodstream. So particulates can deliver acid, and then when they play with your respiratory system, that can be really damaging to you. You don't want to breathe that. Acids are bad reproduction and respiration. So, okay. Anybody want to talk more about acids? Because I want to talk about atmospheric inversion. Okay.
But I do have one question.
Sure, bro. What's your question?
You say that like they're harmful reproductively.
What?
They're harmful for like amphibians that reproduce in the water.
Yeah.
Is that like because the acid is like actually harming those animals' genitals, or is it like the actual?
No, it's the gametes.
Yeah. Okay.
And not just the gametes; it's also the embryo.
So like the embryo has to actually make contact with.
Wait, an embryo is not a gamete. Isn't a gamete from the egg?
Oh yeah. Sorry, I was thinking of that. So the acid has to actually make contact with the gametes, not just like frog wieners are harmed by.
No, I don't know any reason why the frog's wiener would be especially susceptible. Technically, it's a mucous membrane, so maybe the certain parts of a lemon, but they range a lot, even in low acidity lemons that are a lot higher. So anyway, it's the delicate cell, this is mucus coating, the sperm, the egg, and the egg, fertilized egg itself. Yeah. All right. So, how many of you have actually seen smog, by the way? Like, have a visual memory of smog?
Yeah.
And it was like a thin brown slice in LA, I'm guessing. Anybody seen smog in another part of the world? Where? I can explain both of those. Where else?
Mexico City and Paris.
Paris, I'm not sure I can explain. Does it have a river going through it?
Well, the second, yeah, the river.
Okay. And I always thought it was pronounced Spain. Stan?
I pronounce it fine.
I believe you. And it's not otherwise coastal. Paris is not on the beach. It's inland and on the river. Okay. Well, yeah. Not only can I explain it, I too have seen it. Yeah.
Bangkok, Thailand.
What kind of? Can you tell me about the physical layout of Bangkok?
Like huge city layout, lots of big
Landscape. I mean, sorry.
like big fields. There are a lot of rivers running through it.
Is it a mountain valley?
I don't think so.
Is it coastal, like on the beach? Does it have Bangkok have a beach?
Yeah, I mean near it, not where I was, but
Other parts of Bangkok beach to see. Cool. Then I can explain why it gets smog. And actually, I don't think that was smog.
That was smug.
Just saying. San Jose, definitely. San Francisco, if it has smog, I'll bet you it's a transit, an unusual transit situation. Yeah. Yeah, Mountain Valley. Yeah, I can explain that one too. Okay, watch this. There is a normal atmospheric condition. What is the heat source on land?
The sun hitting the ground.
Yeah, it's the land itself. And what do we all know about hot air? It has one behavior you can always expect.
Rises.
Why?
It's hot.
Because it's excited.
It weighs less.
It's going to the low pressure zone.
And you're right, but why?
Because it's going to the low pressure zone.
Yeah, you have high pressure where you have high heat, right?
Mm-hmm.
So the heat source is like pushing away the air because it's pressurizing it, and that wants to expand to where it can expand in the absence of pressure, the low pressure. Does that make sense, everyone?
Yes.
So what that means is, since the city is on land, and land is the heat source, most of your pollution in a normal place goes up away from you, into the air up high. This is normal. This is most parts of the world and most times, but not everywhere all the time. Sorry, I had to send Naomi a message about it. Now, sometimes that normal scenario doesn't pan out. So, let's take a look at my favorite place to hate, even though I live there, Los Angeles. From anywhere you are in the class, you can see the problem. If you look up here, you've got that little green dot surrounded by mountains with a big desert to the east. This will not work out. We should not have put a city there. That was, I mean, there's a million reasons why we shouldn't have put a city there, by the way. But the primary problem for Los Angeles is you have one of these, a basin surrounded by mountains. Now, essentially what this provides is the opportunity for hot air to form and cold air to sneak in, like this. In the Mojave, hot air rises. In the LA basin, cold marine layer moves in. So there's basically 3 steps required for Los Angeles. Whenever you get all 3 of these steps, you'll get smog that day. Step number 1 is cold marine layer has to be pulled in by yesterday's evening rise. If you're watching Los Angeles from like up in the Hollywood Hills, the sun will set, the smog will break up, and then you'll see overnight the marine haze moving into the basin as the air that used to be there has finally risen, sucking in the cold air from the ocean. Does that make sense to everyone? The warm daytime air rises, and that pulls in marine layer. Cool? Then, the next thing required in order to get smog is it has to be a nice sunny day in the Mojave Desert. They get sunrise before the city. You guys realize the sunrise is over here? So sun rises, heats the Mojave, and that makes a body of hot air which wants to spread out, and it makes a cap over this cold air. So now, through the course of the day, even if this starts to heat up, it's still hotter up there, so air pollution is trapped because heat equals pressure. It works like a lid. Watch over here. If you're copying, I understand, but this is kind of clutch. This is still the heat source. So you still have some hot air rising. Pollution rides that updraft. But as soon as it runs into something hotter, it can't move through that. You've lost that pressure differential that causes hot air to rise. It's like hot in the cold, hot in the cold, hot in the cold. Hot against hotter will get turned around. It's trapped. Everybody feel what I'm saying with this? So, instead of the pollution escaping your city, which is normal, you get an atmospheric inversion condition, or a temperature inversion, or an inversion layer, a pollution trap, smog trap. You see that warm air is high pressure, so it's literally pushing the risen pollution back down. Now, all day, this cannot break up until the rising hot air is even hotter than the inversion layer. Does that make sense? Then things can get through. So usually it works like this. Watch me. Sun rises, this gets hot, expands, traps pollution. Even when the sun is directly overhead, now you've trapped so much pollution that you're shading the city. So this won't heat up as much as the desert beside it, and that maintains the inversion layer until the sun keeps going, until the Mojave's in the shade. Once this is in the shade, then you stop that, and only around sunset does the air from here beat this pressure and finally escape.
So it's high pressure, low pressure, high pressure?
Yeah, pretty much. High pressure, low pressure, slightly less high pressure on the ground.
So we have a pretty similar layout in San Francisco.
Not really. For one thing, the mountains are to the north of us, and they have a separate outlet. So those mountains to the north of us, they suck in cold air in the Santa Ynez River mouth at Ocean Beach by Lofton. And so they suck cold air in from the ocean up the Santa Ynez River bottom. And so the other side of our mountains have both a cold intake and a hot, so that stuff just goes up. Second of all, we do occasionally get some hot air coming in, but we're not trapped by mountains. We are on the side of mountains. So we still have lateral flow up and down. We're not in a basin. We're on a shelf.
Why does a marine layer like this ever get caught up or not?
That's a neighborhood. That's a temperature differential. Same as this. Same kind of marine layer as this.
But it's still going to say, well, that's better than having to do it.
Well, it has more access. Well, no, it also has access to the marine layer, but it doesn't have the Mojave on the other side to cap it and hold it. So our marine layer breaks up, unless you're in those little tiny pockets that hold that only seasonal, only in June gloom, when you have that specific differential between nighttime temperatures and morning temperatures. Once you've built some thermal mass on land, you don't need to get marine layer here. there may be other reasons too. I mean, I know that one of the big deals is that this is a basin, it's like a bowl. If you blew out the Palo Alto hills, the PV hills,